Lesson 4.3, Video 2. So let's look at specific examples. Determine whether each expression is a polynomial. So is it a polynomial or not? And then identify the polynomial as a monomial, binomial, or trinomial. So our first one, we look at this and we see that we have two monomials, and it's okay to have two variables next to each other like the xz. There are two monomials subtracted. So this is yes, it is a polynomial. There are two terms, so to be more specific, it is a binomial. Our next one, it is a constant, but we can also call that a monomial. The next one, we have what looks like a binomial. There's two terms. But if we look more closely at it, this power of 3, as discussed, tells you that it's in the wrong position. And this is over 1. So this actually is 7 over a to the third power. Now, because there's a rule that says you cannot have an exponent, or excuse me, a variable in the denominator, it does not qualify to be considered a monomial. Therefore, it is not a polynomial, because a polynomial is a collection of, by addition or subtraction, monomials. So because the a, even though it looks like it's in the numerator here, the negative power tells you that it cannot stay there, so it must go below, which means now you have a variable in the denominator, which means it is not a monomial. Therefore, the whole thing is not a polynomial. Our next one, we have what looks like 4 terms, which we would call a quartic. But if you look more closely, you'll notice that 2 of them are like terms. Right here. So this is actually 6x squared plus 5x plus 3. So when we clean it up, we see that we actually have only 3 terms. So therefore, instead of calling it a quartic, we will call this a trinomial. Our next one, again, if you notice, we have a variable in the denominator, which means no. You cannot it is not a polynomial. And our last one, we have a -3, but that's a coefficient, and that's okay. We just have to look at the powers, and the powers are all positive, so and there's no variables in the denominator, so this is yes, and it is a trinomial. Now let's discuss the degree. Okay. Now notice that we have 2 variables right next to each other. And this is an interesting question. So all the other ones had just one variable with an exponent, and it was very easy to decide what the degree was. But when we have variables multiplied together, now this is a binomial. There's 2 monomials there. But when we describe its degree, if by chance 2 variables are multiplied together, then we will take the sum of their, even though they're different bases, the sum of their exponents to help us decide what the degree is. So this has a degree of 5 because we add the exponents to decide the degree. Now we don't add them together when we're simplifying because they are different variables, but when we decide the degree, if they're multiplied, we will add their exponents. So if we look at the next one, we have a degree of 5 right there. Those 2 together give you a degree of 7, and then this has a degree of 0 on the 7. There's no variable there, so it's degree 0. So we will take the monomial that has the highest degree, so the degree will be 7. Okay, the next one we have a monomial. This has an exponent of 1. The c has an exponent of 1. So this would have a degree of 6. Okay, now that's just a monomial, so we'll take the highest power added together. Okay, so our last one here, if we look specifically at this part here, this has a degree right here. That monomial is a degree 2 because it's a power of 1 and 1. This has a degree of 3. This has a degree of 5. And this has a degree of 0. So the highest one is this one. So this is degree 5. And this ends lesson 4.3, video 2.